Okay, so in this video, we're going to introduce the idea of polar coordinates. So far, everything we've done has been in the standard XY plane. Okay, so we have our X, we have our Y. But there are certain curves that don't make a lot of sense to study in polar form, in Cartesian form. So this is called Cartesian. This is your Cartesian form, and XY, your point right here, is a Cartesian point. Okay, so there are certain curves that don't make sense to study in, or that are really difficult to handle in the Cartesian plane. And so what we're going to start to look at in this lecture, or this set of videos, is what are called polar coordinates. Okay, so uh, polar coordinates, we're going to choose a point called the pole, and then we're going to draw a ray or a half line out of that. It's usually drawn as the positive x-axis, and this is called the polar axis. Okay, so whereas we would define our point xy as number of units to the right is the x-coordinate, number of units up is the y-coordinate. What we're going to define our point P here is going to be defined in terms of two things still. One of them is r, the distance from the pole, and the other one is theta, the angle from the polar axis. Okay, so r, theta. Okay, so let's look at an example of a couple polar points. Okay, so let's draw the polar points. Okay, we're going to here, we're going to draw the point 1, 5 pi over 4. Okay, so there's our pole, there's our polar axis. We need to go 5 pi over 4 from the polar axis, always going counterclockwise. Should be something like this. Here, this distance is 1. So that means this point here, if this is 5 pi over 4, is that angle. Then this is the point 1, 5 pi over 4. Okay, but the way we've defined this, nothing we've said has told us that r has to be strictly positive. Okay, so let's try this. Okay, and this is an important distinction and something that can be really hard to grasp, or a little challenging to grasp the first time you see it. Okay, so we're going to go negative 3, 3 pi over 4. Okay, so there's our pole and our polar axis. We're going to go in the 3 pi over 4 direction, so 3 pi over 4 should be about there. Okay, and we can think about drawing a line here. Everything on this line has theta equals 3 pi over 4. Now, if r was positive, we're going to be up here. If r is positive, we are up here. So here's r bigger than 0. But if r is negative, r is going to be down here. Okay, so we think about going in the 3 pi over 4 direction. The positive direction is going in the yellow part of the curve, and the blue part's going to be r's negative. Okay, so we're going negative 3, so we can mark off 3 units. like this, and there's our point, -3, 3 pi over 4. Okay, so this brings up, this alludes to something that can be a little challenging to deal with, or another challenging aspect of polar coordinates, and that's that a point P written as r theta is not a unique representation of the point P. Okay, so we can view this a bunch of different ways. Okay, so for n an integer, we can write it like this. Because really what we're doing when we add 2m pi is we're just going around the circle another rotation, in which case the angle is still the same. We've just gone around the circle another time. This should also be the same as this. Okay, and this is for integers p. Okay, so if I really didn't want to write point 2 that we had from before with negative radius, like maybe that's the directions in some hypothetical homework problem, we can rewrite this so that way the radius is always, the radius is positive. So we could rewrite this as 3, but then we could add pi to the angle. Okay, so if we add pi to the angle, then we would get 7 pi over 4. Okay, so those are two ways to write the same point. We could also write this as 3 negative pi over 4. Okay, so 3 different ways we could write the same point. Okay, but now at this stage in our mathematical careers, we have looked at we've been working with Cartesian points for so long, it's often nice to think about how do these things interact with one another. So we should also be able to convert our polar point P between Cartesian and polar form. Okay, so converting between Cartesian and polar form. So one way we can do this is let's just draw a picture. So I have a point P right here, and I know I can write this point P as xy in Cartesian form. Okay, so if we're drawing this somehow, we usually think about the origin being our pole and the positive x-axis being our polar axis. So if we can find this here, that r, that distance from the origin, and that angle theta, we can do that. So, or then we can write this in polar form. So we can write this as r theta. So the one way we can go about doing this is we know that r squared has to be x squared plus y squared. Because if we draw this, this distance here is y, this distance here is x, and we form the right triangle. So we can use the Pythagorean theorem. And we know that tangent of theta is then y over x using this same triangle. Okay, so something you need to be careful of is it is tangent of theta is equal to this. This does not always mean that tangent inverse of y over x may not equal theta. Okay, and that's because the range of tangent inverse is going to be from negative pi over 2 to pi over 2. Okay, so for example, if we have a polar point over here, and you take tangent inverse of the y over x, you're going to wind up with an angle that is down here. Okay, so that means that angle is okay in terms of finding the angle, but going back to what we were just talking about, then r is going to end up being negative. Okay, so this takes care of going from Cartesian to polar form. What about going the other direction? What if we want to go from polar to Cartesian? Okay, so here's our point P. Our point P we can write as r theta. So there's r, there's theta. We want to be able to find y and x. We can find y and x using trig. So our x coordinate is going to be r cosine theta, and our y coordinate is going to be r sine theta. Okay, so using all of these, so using the fact that r squared equals x squared plus y squared and tangent theta is y over x, we can convert from Cartesian to polar coordinates, and using r cosine theta and r sine theta, we can go convert from polar coordinates to Cartesian coordinates. Okay, and we'll come back and talk about polar curves.